In this video, we'll be talking about cement. Specifically, I'll be describing what cement is, the history of cement. We'll be having a look at one of the most common types of cement, and that is the ordinary Portland cement. And then we'll look at some cementitious products. And then finally, I'll talk about the transportation of cement and its setting time. So what is cement? It's the binder in concrete, so it's the active component of concrete. There's various cement types, so you can get slag cement, silica fume cement, and many others. The focus is mostly on Portland cement, OPC, as this is the most common type, and this is what we'll be focusing on in this course. So some history of cement. Just like concrete, cement dates back to more than 2,000 years ago, and it goes back to the ancient Romans and Greeks. It's hydraulic cement as we know it today. The reason that it's called hydraulic cement is because it undergoes the chemical reaction of hydration in order to achieve its solid state. Now, traditionally in Italy, back in Pozzuoli, there was a rich volcanic ash that was available for people to utilize and mix with cement, and hence that's why till this day any of the aluminosilicates that are present in cement are referred to as pozzolans in reference to that city in Italy. The term itself, cement, comes from Latin. The main compounds of cement. There are four main compounds, as you can see on the screen in front of you, and this is their chemical formulae. So the first compound is tricalcium silicate. Second compound is dicalcium silicate. The third compound is tricalcium aluminate. And then finally you have the tetracalcium aluminoferrate. Now the names are a bit huge, so to make our lives a bit easier, what happens is that we adopt an abbreviated name. So for instance, and the formula is abbreviated as well, you can see that for tricalcium silicate, it becomes C3S. Now the C over here refers to calcium oxide part, and then you have the S, which is for the silica component. And given that we have 3 calcium oxides in the formula, we have C3, and then the S is for the silica, as I said. The abbreviated name for that is alite. For dicalcium silicate, it's C2S, abbreviated name is belite. Tricalcium aluminate, it's C3A, and it's referred to as aluminate. And then finally we have the C4AF, and that's your tetracalcium aluminoferrate. And for that, we just basically refer to it as ferrite. The most common type of cement, the ordinary Portland cement, was first produced in England in 1824. As I said, it's the most common type that's used worldwide. It's a hydraulic cement because of the process of hydration, and it's composed primarily of hydraulic calcium silicates, as we will see in a different video when I talk about the hydration process. Now, the main components of OPC, ordinary Portland cement, there's limestone, and that's the main component, of course. Then we have shale, clay, silica sand, slag, and then iron ore. When you mix the cement with water, that's what gives you your adhesive paste in concrete. And that adhesive paste holds together the aggregates. Now, through the process of hydration, which is a chemical reaction, the concrete itself becomes hard. And to control this hydration process, we look at the water to cement ratio, and that is the mass of water to the mass of cement. And depending on our applications, we can play around with this parameter a bit, as I will be discussing with you in a separate video. Now, OPC, when it's produced, you got to make sure that it doesn't contain excessive amounts of lime, magnesia, and calcium sulfate. So for instance, magnesia can be present in up to 4.5% of the total volume of your cement final product. The reason for that is because we're trying to avoid any reactions with the aggregates eventually when we mix the whole constituents together. In terms of the cementitious products that are common when it comes to cement, the first primary product, if you like, is grout, and that's basically obtained through mixing water with cement. The second product is mortar, and that you obtain by taking the grout and then including fine aggregates and mixing it together. And then finally you have your concrete, and that's produced by mixing the mortar with your coarse aggregates. So the concrete would include cement, water, fine aggregates, and coarse aggregates. Finally, when it comes to transportation and setting, transportation of cement is very important. We need to make sure that it's transported through dry conditions. And the reason for that is because we don't want any water interacting with the cement particles and then initiating the process of hydration. Otherwise, it's useless. In terms of setting time, it's controlled through the chemical composition of cement itself, as we will be describing in a separate video. But you can think of setting time as the time needed for the cement paste to solidify in concrete and reach the desired strength for that concrete. It's important to understand setting time of concrete as it's associated with the enhanced compressive strength of your concrete.